Alright, here's the second part of 11.2. We're going to talk about the area of a rhombus. Alright, so the area of a rhombus can be found by taking the diagonals of a rhombus, multiplying them together, and then timesing it by 1/2. So the area of a rhombus is area equals 1/2 d1 times d2, or you could just say d1 d2 over 2. Same idea. So we have another little problem here where we're going to plot these points. I think this is something you guys could probably do on your own for the most part, so I'm going to let you guys try it, and I'll have the answer up here shortly. So go ahead and plot the points, and then see if you can't just take the diagonal measures, multiply them by each other, and then divide by 2. Okay, go ahead and give it a shot. Alright, so when I plotted these points, I got this rhombus right here, and the diagonal up and down was 8, the diagonal left to right was 6. So I'm just going to come over here, plug that in. Area equals 1/2 8 times 6. Well, half of 8 is just 4, and 4 times 6 is 24. So we have 24 units squared. Boom, done. Alright, well, let's go on to the next page. Okay, this one says that rhombus WXYZ has an area of 100 square meters. Find WY if x equals 10 meters. Well, my thing is, I like pictures. There's no picture here, so I'm going to zoom in and try and draw a picture of WXYZ. And I know it's a rhombus, so draw a diamond-looking thing here. Label it WXYZ. And let's just fill in what I know. Well, I know that XZ here is 10, and they want me to find WY. Well, I also know the area is 100 square meters, and I know the area of a rhombus is 1/2 d1 times d2, and this area happens to be 100 times 1/2 times my d1 we'll say is 10, and we'll say d2 is WY, what I'm trying to find, okay? Well, half of 10 is just 5, so I have 5 times d2 equals 100, and then divide by 5, and 100 divided by 5 is 20, so d2 has to equal 20, or we could say WY is 20. And there we go. I worked backwards and found the missing length. You guys are going to do the same thing here for the next problem. Only this thing is not a rhombus, it is a trapezoid. So, same idea. You might not even have to draw it out. You probably go straight to the formula if you want. But I like having the picture. It helps me quite a bit. So, go ahead and give that a shot, and I'll have that one up for you in just a little bit. Okay, real quick, I forgot to say meters here because we know we're dealing with meters, so I should have put in a little meters on this last one. And now on this one, we just used the trapezoid formula and we work backwards. We got 250 equals 1/2 the height times 20 plus 30. 20 plus 30 is 50, and half of 50 is 25, so you divide both sides by 25 and you get the height is 10 inches. Simple as that. Alright. Last thing here, congruent figures have equal area. Equal area. So if I have two figures that are congruent, they have equal area. Well, let's read this summary problem because I'm going to do a little bit of it with you guys. It says this block pattern is composed of 12 congruent rhombi arranged in a regular hexagon. The width of the hexagon is 8 inches. If the total area is 48 square inches, use postulate 11.1 to find the area of just one rhombus. And the length of each diagonal of the, there's a typo there. So the lengths of each diagonals of the rhombus. So we want the length of a diagonal of just one rhombus. So what we're looking for here is area of just a rhombus. So I'll put area of rhombus, and then diagonal 1 and diagonal 2. Now, the area of the rhombus should be pretty easy to figure out because they told us the total area is 48 square inches. And they also told us there was 12 of these guys. So if congruent figures have equal area, that means that 48 square inches has to be equally spread among these 12 rhombi. So I'm just going to do 48 divided by 12, which is, 48 divided by 12, which is 4 inches squared. Okay, the next thing, I'm going to have to find the diagonals. So I'm just going to leave this for you guys to do. But remember, they did say that, if you look up in the notes, they say that it is 8 square inches. Yeah, 8 inches across. So that means that this distance here is 8. Well, you could use that to find at least one of the diagonals, and then you might be able to use a certain formula to find the other diagonals. So give that a shot, and I'll see you guys in the next video.